Good morning everyone. Myself Professor Purnima Raikar. Today I am going to give lecture series on automata theory and computability with subject code 18 CS54, module number 3, lecture number 40. Now before we start with today's topic, we'll first understand what is NBA, what is course learning objectives, course outcomes, Bloom's taxonomy. Now NBA stands for National Board of Accreditation, that is outcome based education. So every course what you learn, you have course learning objectives and course outcomes. And teaching learning process is in a form of a pyramid, that is it is been arranged as a levels based on Bloom's taxonomy, where we first remember the concepts, then understand it, then we apply for a particular situation, then we analyze it, evaluate, and then create. Now today's topic, what we'll be covering, the students will have better understanding of simplification of grammar. Now in the previous class, we have studied context-free grammar, how to obtain context-free grammar for a different languages, and how to, we have also studied in the first module finite automata machines, regular grammars. Now we'll see how to simplify the given grammar. Now course learning outcome is third one, that is designing a grammar and automata for different language classes and become knowledgeable about restricted models of computations, their relative powers. Now taxonomy is second and third. We will understand the concepts and we'll be applying it to design and simplify the given grammar. So now I'll share the Word document file. Is this visible to all? Okay, now in the previous class we have understood Chomsky's hierarchy for context-free grammar, that is type 0 grammar, type 1 grammar, type 2 grammar and type 3 grammar. We have also understood what is context-free grammar. So grammar is defined as 4 tuples, that is we have set of variables, non-terminals, set of terminals, start symbol and production rule. So all the grammar will be defined with respect to 4 tuples. Now we have studied how to design a grammar for different type of languages. We also studied what is ambiguous grammar, that is when we have two distinct parse tree, we say it as ambiguous grammar. We also studied in the last class in inherently ambiguous grammar, that is a grammar for which all the rule or all the productions from the start symbol are ambiguous. We say that grammar is inherently ambiguous grammar. We have also seen how to remove ambiguity from the grammar. Now today we have understood, that is given a grammar. Now they have given you a grammar. Now we'll just see now rules what you define for a grammar. Say for example, I have a rule defined this B which is having A. So now if you see, if I want to go for derivation of any string, I will just use A and B and I'll apply A with A and A with, I can apply A with A and B with B. But just if you see C I am not using from the start symbol, C is given, but with the C I cannot generate any string or any terminal string. So I cannot generate any terminal string. Just a second. Okay, sorry. Is I audible to all? So now if you just observe from S of C, when I apply for derivation, any left or right derivation, any derivation, I cannot generate anything from C. That means C is not useful in this grammar rule. So simplification of grammar means I have to remove those rules which are not being useful. That means a rules when I want to apply simplification to a grammar, I'll simplify the grammar by applying what I have to remove those rules which are not useful. That is, the rule, if it is not useful for generating a string, I say those rules are not useful. So I have something called as removing or elimination of useless rule or useless production. So simplification of grammar, there are three types. One is removing useless production. Next is removing epsilon or lambda production, that is null production rules from the grammar. And third one is removing unit production rules. So the grammar which is not useful or which is not useful in generation of terminal string, I say those are useless grammar or that those are not useful. So when I say now S of C, it is nothing but a useless rule which is not been used to generate any of the string. So same way we will have sometimes epsilon which is not used in your rule. If it is not used in a rule, that means it is an useless lambda production. Same way unit production. Now when I say unit production, when you have both side capital letter, that is when you have both side variables, single variables, I call those as unit productions. So in some cases, like here see S of C, it is also an unit production because you have a single variable here and a single variable here. So if it is not used in generation of your string, I can even eliminate that. So simplification of grammar has three forms. One is removing useless production, second one is removing lambda production, and third one is removing unit production. Now we will see one by one how to eliminate this. So I think it is now clear which grammar rule I say it has useless or I say it has epsilon production or unit production. Now given a rule grammar, I have to see whether they are useful or they are not useful. Now we'll see one by one these rules. So I'll just take an example. Now first we'll see simplification of grammar. In that first we'll see removing useless production or useless rule. So I can say it as removing or elimination of useless productions. So now these things we'll be explaining with the example only. So first step for removing useless production is we'll just take an example here. S of AA PP. So I am taking the rule which has been given AA, then B of BB, then D of AB EA and E of AC D. So this is the grammar given. So I'll first go for elimination of useless production or removing useless production. Now first step in this, see they have given you the rule. Now which are useless or which rules are useless? First step is identify the rules which tends to terminal string. Identify the variables. Here see variables means non-terminals, all your capital letters. Keep this in mind. See when I define a grammar, it has four tuples. One is your variables, that is non-terminals. So all the capital letters in this rule are your non-terminals or variables, and all your small letters like A, B, small a, B, all are your terminals, that is inputs, whatever you give. So in this case, you can have all your letters, small letters, then you can have your operators, keywords, identifiers, all come across terminals. Same way you have start symbol. So here start symbol also is yes, and P is the rules, that is this part only. So P are the production rules what is been given. So now we'll first see what is the first step to remove useless production. So first step is identify the variables which tend to terminals. That means which can generate terminals. So second step is identify the variables which are reachable by, which are reachable from start symbol. So which are reachable from start symbol using dependency graph. So what is the first step to eliminate useless production? Identify the variables which tend to terminals. Second step is identify variables which are reachable from the start symbol using dependency graph. So these are the conditions. Now we'll apply it for this grammar now. So in this grammar, so I'll note down this here. So we'll just start from the first step. So I'll just take first step. So what I have to do, identify the variables, that is non-terminals which tend to terminal. Now you just take first one, S of AA. Now for A, I can substitute small a. That means I can substitute AA or AA also. So that means I can any time if I'm applying. See, there is something called as substitution rule. Substitution rule means I'm applying the rule what can be applied for this capital letter. So this is called substitution. See, A can be substituted with small a or capital A. Then again this capital A I can substitute it with A. That means S will generate with this rule terminals. So I'll consider this. Second, what is the second rule given? Now second rule is S of BB. So S of B. Again I can see B. This capital B I can substitute it with capital BB. But I don't have any chance where I can substitute this capital B with any of the small terminals. That means from S of PB, I cannot generate terminal string. So first identify the variables which tend to terminals. So first one is this one. If I use S of PB, BB, for B, see, maximum B has only one substitution, that is BB. That means once again B can be substituted with capital B, but always one capital B will remain. That means I cannot get from this rule all your terminals. So I cannot take this rule now. So I'll just put cross mark. Second one. So A can substitute small capital AA. And you have two rules for A. So A of AA, I can substitute A with A. That means I can generate terminals. This is as such given only is terminal. So I can consider this. Third rule is again PB. So if I again take this PB, this B, I cannot replace it with small letters, any terminals. It is always your non-terminal only. It will remain. So I cannot take this. Next is D with AB. So AB already they have given you terminals, so I can consider. Next with EA. Now if I take E can be substituted with any of the small letter. Yes, E can be substituted with small d. So I can use this or both I can use. So or I'll just write this separately. So again next with D is EA. So E can be substituted with D. Fine, this I can consider both because both will generate terminal string. So tends to terminal string means both generates terminal string. Next you are left with AC. Now if you just see AC, for C they have not given any substitution. That means C cannot be replaced with any small terminals. So I cannot take, I'll not take this. Next one E with D. With D because generating terminal string I can consider. So which are the after first step, what are the rules I got? So this I can consider it as this is P, I'll consider this as P dash. So what are my P dash now? S of AA, which tends to terminal, then A with AA and A I can consider, then D with AB I can consider, D with EA I can consider, and E with D I can consider, but not AC nor BB or BB, because B always remains capital only in that case. So after first step I got this. So this is my first step for removing useless production. So first you identify all those variables which tend to terminal string. Second step, what is second step? Using dependency graph, I have to identify the variables which are reachable from the start symbol. See, from the S, see if I put S here and from I put A, D, E, all the letters if I put from S, I can only reach to A. I can only reach here. But from S, there is no rule defined for D. There is no rule for E. That means from S only I can reach to A. So using my dependency graph, I came to know that I can only reach from S to A. That means I'll only consider these rules. So all these rules will become useless, because from S I have only AA, which is I am reachable to A but not to D or E. That means this is my only S and A are my useful rules. So this is how we eliminate useless productions. So this is how we eliminate useless productions. Is this clear? So first step, once again we'll recall, that is for removing or eliminating useless production, first rule is I have to identify those variables which tends to terminal. So all the variables which can generate terminal, I have to identify that. So that will become my P dash. Next, second step is by using dependency graph, I have to see, or just by seeing this, I can understand S is reachable to A, but S is not reachable to D and E. That means finally my production rules, what I get by eliminating useless productions are only these two rules. So all these other rules are useless rules. So in this big grammar, only this and this are useful. Not even this is useful. All these are useless rules. And even I can say this has useless variable. So in this case, which is useless variable? B is useless variable and C is useless variable. Why? From B and C, I cannot generate terminal string. But not S is useless. S of PB is there. This rule is useless. But S is useful because from S I can generate my terminal string, and S is my start state, start symbol. So I cannot say this has useless. But in this case, B is useless, E is useless. At the first step, I can say these two are useless because I cannot substitute B with small letter nor C with small letter. That is my terminals. I cannot substitute it with terminals. But E I can substitute. But when I go for second step with dependency graph, I have to eliminate also C because S is not reachable to E. So this is how we solve elimination of useless grammar. So we'll just take another example. So elimination of useless production. So again, one more example we'll take. So S of AA so small c is terminal, then capital C also they have given. Next is A, and D with this. So you have to eliminate useless production. So first rule is identify the variables which generates or tends to terminal string, terminals or terminal string. So first is we'll see this S of A rule. So A can be substituted with AB, then B can be substituted with A. That means from S of A I'll get all terminals. So I can take A, this. Second rule is S of A. This is has such given only with small letters, so I can consider that. Then S of BB. You have to check with all. So S of BB. So B can be capital, B can be substituted with small a. So it will become AB. So I can consider that. Then S of small c, capital C. See, small c is terminal, capital C is non-terminal. That is your variable. So C can be substituted with A. That means I can generate from this also terminals. So next is AB. So AB. So first I'll consider this as B, and this what I'll get next, I'll consider this as B dash. So next I'll take A with AB. So A with AB, yes, B can be substituted with small a. That means I'll get all terminals. Then B with A, there is no question to check this because it is already small letter. Then A. I can substitute A with AB and B can be substituted with small a. That means I can only also consider this rule. B of A also can be considered. Then C. C with small c is there. Capital C, there is no rule given for capital C. That means capital C cannot generate for terminals. So I cannot go for capital C. You can have A and for capital C also you can have A. That means small c A you can substitute, and for D you can substitute small d. That means I can consider this rule also. That is, I can consider the rule C, capital C, D. And C with A I can directly take. Then D with A, D I can take. That means in this given rule, when I apply first step, I can take all the rules because all generate terminals. Is this clear? So second step is what? Using dependency graph, I have to see whether from the start symbol, which are the variables which are reachable. So using dependency graph, I have to check which are reachable from start state. So I'll just take yes. I'll put all yes rule in one just to see. Next A, they have given AB, and with B there is A, and with D you got C, and with D you have DD. So now I'll just put the dependency graph here. So I'll just put the dependency graph. So I'll just put here dependency graph. So using dependency graph from yes. See here, with this we can see easily yes is reachable to A. That means from A I can reach. Then yes, you have A also. From S you can also reach to B, because from S there is a rule defined for B. Then for C you can easily reach to C because C. So C is also an input which can be reachable to, which can be from S you can reach to C because small c is there, and this capital C I can substitute it with A. So I get terminal string. So from S you can reach to A, C, B, but you cannot reach to D. So which is your product? Which are the useful productions? Only from S whatever you have. You can reach to C also. So from A you can have A productions because from S you can reach A. From S you can reach to B also. So you can have B production. And from S you can also reach to C. So you can have C production you can have, but there is a D here. But from S you cannot reach to D because D can be substituted with DD. But C of C you can reach, but not with D. Understanding? So not with D. So I have to eliminate this because S is not reachable to D, and in this C production you have CCD. So I cannot take that. So I have to only keep which one production? C with A. So this is my production rule. What I get by after eliminating my useless productions. Is this clear for everybody? Now just see, I'll just make this question, in this question only slight change, and then you check what will happen. Now instead of with C this, if I don't give A, okay, what will happen when I do first step, identify the variables which tend to terminal string. So I'll just write these all rules. So I just changed my question. I just removed one part of the question, that is C with A. That means I have to use what? S with, I'll get S with A. Okay, A can be terminal, A can be sub-terminal, B. But when C, capital C comes, as I have removed C with A, so I cannot substitute C with, I cannot substitute this capital C with small letter. That means I cannot take this. So this will become my useless, this one rule. But A with A, I can use it. So A with A, I will be using it because I can generate terminal string. From B also I can generate terminal string. Now for C also I cannot have this capital C will always remain, and this D I can substitute it with this, but this C remains as it is. So this also become useless production. And D with DD I can consider in the first step because it generates terminal string. Now what is my second step? By using dependency graph, I have to see from, yes, I can reach to A, I can also reach to B. See, just I have made one rule, I have changed in this my question. What will happen? From yes, I am reachable to A, and from yes, I am reachable to B. So what are my useful rules? For P double dash, it is only with this, with the production A and with the production B. Not also, will not consider D because from yes I cannot reach to D. So this is called elimination of useless production. Is this clear? Is this clear for everybody?
Yes, ma'am.
Is this clear, or any doubts anybody has? We'll take another question to remove useless production. I'll just take one example. Remove useless production. S of AA. Before I take this example, we'll first do one thing. I'll just take unit production and lambda production, then we'll go for useless production. So one example, I told you how to remove useless production. Why I'm doing this is, sometimes in the rule you will have unit production and epsilon production. So in that case you have to remove all and then come for useless production. So just for a change, I'll just take example of one example for useless production. So if this is there and they have asked you to eliminate useless production. So first they have given this and they have asked you to remove useless production. So which is in useless variable? With this only I can understand. See, first step is I have to identify use. So useless variable is nothing but useless production. So what is useless variable? The variable which is not helping you to generate or tend to terminal string. So first step is identify those variables which does not generate terminal string. So if I take A, I can substitute it with AB, and this B I can substitute with AA. That means from B there is no any chance of generating terminal. So from S I can only take A. So in that case, first step when I apply, see if you have for B somewhere something has B, then A can be substituted with AB and B can be substituted with B. That means I can consider both. Okay, if the rule is given in that form. So A, B also I can consider because B can be substituted with small b. B also I can consider. But with D, I don't have any with the D, in the first step I can consider because all are your terminals only. So I can take this as B dash. So this is my B and this is P and this is my P dash after applying first step. So what is my second step? Draw dependency graph and check where you can reach. From S, I can only reach to A. That means I can only have A's production. I cannot have B's production. See, from this, S can be reachable to A. From A, I cannot reach to B. That means I cannot have this also. So my final rule, what is left with me is only this. So all other are useless rules. So this is nothing but how to eliminate useless production or useless grammar from the given grammar. And which is useless variable? These are all your useless variable because they are not used in any of the generation of a terminal string from your start symbol. So this is called elimination, how to eliminate useless productions. Okay, next we'll go with next one. So next I'll eliminate epsilon production. So I'll just go with elimination of epsilon production. Sometimes in some books epsilon or lambda production. So sometimes in the diagram also instead of epsilon they can give you lambda, but both meaning is empty string only. Now what is the step for removing epsilon production? So give all these productions which are of this form. That is given a rule, like for example, I have taken one example. So which is your lambda production or epsilon production, or we say this has nullable productions. So what is the first step to eliminate epsilon production? Whatever productions tend, whatever variables tend to epsilon, we call it as nullable variable, and the production is called as nullable production. So this the production variable which tends to epsilon, I call it as nullable variable, and that this entire production I call it as nullable production. So elimination of nullable production. Now given a rule here, you have to first identify which are the variables which tend to epsilon. Again here we have to use substitution method only. So identify the variables, that is non-terminals, which tend to epsilon by using substitution method. How you did in useless production, that is identify the variables which tend to terminal string by using substitution method only. This you can understand only by substitution method. So here now yes for A, whether they have given epsilon, no, but if you see this, you have B with epsilon, C with epsilon. This is clear. Okay, B tends to epsilon, C tends to epsilon. This is very clear. Now just see whether anywhere you have B, C productions. Now if you just observe here, A, you can see here, if you observe for A, B, C is given. B can be substituted with epsilon. A also can be, C also can be substituted with epsilon. That means A also tends to epsilon. This way of substituting the variable with its corresponding grammar, I call it as substitution. So some are, they have given you directly B with epsilon, C with epsilon. So B with epsilon, C with epsilon are epsilon production. Next is by using substitution method, whether you can get any other epsilon production. Like see for A, you can substitute for B epsilon, C epsilon. That means A also generates epsilon. This you understood by using substitution method. Now just see with D, there is no possibility with D. Yes, you can see A you can substitute with epsilon, B you can substitute with epsilon, C you can substitute, but there is one small A here. So S will not tend to terminal even with this. So first step is to identify all the variables which tend to epsilon production. Second step, now we have to remove this epsilon variables. How you will remove it? You can remove this epsilon variable by replacing with the substitution another substituted variable. That is, now see, for S what they have given, A, B, C, A and B, D. You keep this as it is. Okay, now by this you have understood A can be substituted with epsilon, B can be substituted with epsilon, C can be substituted with epsilon. So original one will keep it as it is. Now first time you substitute this A with epsilon. So I get B, C, A. For next time you substitute all three with epsilon, you get small a. Next, just you have to do this simultaneously. How we will be doing? You know all these variables go for 10 to epsilon rule. So how to substitute it? You have to make some additional variable. That is, you are eliminating nullable variable by adding some new rules by substituting epsilon production. So you can eliminate nullable production by adding some new rules by substitution of epsilon. See, just see, I substituted first time A with epsilon, I got BCA. I substituted all three with epsilon, I got A. Now I'll substitute for B, I get this. Next time I'll substitute for C, I'll get ABA. Next time I'll substitute it for, just this is again, see, you have to just go on doing it alternately. So once I substituted for A, next time I substituted for B, next time I substituted for C, next time I'm substituting for A, B both, I'll get CA. So you have to get all possible variables, all the possible rules which tend to terminals. Understanding? So still you can see anywhere you have this rule once again where you can substitute epsilon. So if you just observe, this is where I can substitute epsilon. So I got AB epsilon, I got CA. Next I'll substitute for AC epsilon, I'll get BA. Next I'll substitute for BC, I'll get AA. So these are the rules what I got by substituting the epsilon rule for A, B, C. Alternately, I have to substitute A, B, C with epsilon rule. So this is how I get the rule. Next, again, I'll check with the next one. So what is the next rule they have given? A with BC, B. So again, A with BC, I'll keep this original one and then again I'll substitute once B with epsilon, I got C. Another I'll substitute with C epsilon, I'll get B. So this is the rule what I got by substituting epsilon. So as original rule is BCB, then you substitute alternately epsilon for B and C. Next with B. So I'll not take B with epsilon because I am eliminating it. So I'll only take B. Then C with small c. Then D with D. So this is what I got by after eliminating my epsilon production. So this is the rule what I get after substituting epsilon production. Is this clear for everybody? So how to eliminate epsilon production? So epsilon production, first step is first identify all the variables which tend to epsilon by using substitution method. Second is you have to remove epsilon variable or epsilon production in such a way that you alternately substitute epsilon for the variables and you get new rules. So this is how we remove epsilon productions. So we'll just take another example. Is this understanding? You are understanding these concepts? So I'll just take another example of epsilon production. Epsilon, or you can take lambda production. So we'll just take another example. BAAB, A with 0, A2, 2A0 epsilon, then B with AB, B, 1B epsilon. So this is the production what is been given. They have asked you to eliminate epsilon production. So first step, you first identify which are the variables which tend to epsilon. By seeing this, you can easily make A tends to epsilon, B tends to epsilon. Now just see if I substitute for yes, A with epsilon, B with epsilon. So A also generate epsilon, B also generate epsilon. That means these all you can substitute with epsilon. So these are this is my first step. First I'll go for direct epsilon rules. That is A with epsilon, B with epsilon. Now then check for using substitution method, check that whether other variables also tend to epsilon production. That is, if I substitute for B epsilon, A epsilon, again yes also generates epsilon rule. So this is my first step. Now second step is you have to go on adding new rules by alternately substituting A, B and S as epsilon, because these are the variables which are nullable, which generates nullable. So I'll just take first rule. So first keep the things as it is, then go on doing it alternately. So first part you will keep this as it is, then first time I'll substitute for A epsilon, so I'll get B AB. So next time if I substitute this also, I'm getting a BAB only. I'll keep one BAB. Then I'll get BA. Then I'll get AB. Alternately, first time 1, second time 2, next time 3. So first time I'll start with 1. That is, I'll substitute for A epsilon. I'll get BAB. Next time I'll substitute for these two. I'll get BA. Next time I'll get AB. Then I'm getting AA. Next I'll get BB. So alternately I have to get all the possible productions. So next I'll get BAA. So I am substituting for this B, I'll get BA. So you can follow what? First 1, next 2, next 3. So how convenient you will feel, you can do it. So next I'll substitute for all. I'll get 1A. I'll for all. Then I'll get B. So I can try all these. AA I can get, AB I'll get, BB I'll get, then AB I'll get, BA I'll get, BAB, then AAB. So alternately you have to go on substituting one by one. So once you will substitute for A, next you will substitute for B. So here once you can go for this A, first B, next time you will go for last B, next time you will go for this A, next time you will go for this A. So alternately once you can start with 1 substitution epsilon, then for 2 substitution epsilon, then for 3 substitution epsilon. So all the possible rules you will get. So these are the possible rules what you got by substitution. Next is with A. So you know for A, original one you keep it as it is. Always first part you keep the things, but you cannot keep this epsilon because I am eliminating it. So now go for alternate. Now you know A tends to epsilon, so I'll get 0, 2 if I substitute for this A. Next I'll get 2, 0. So I don't have much changes here. So I have only A epsilon. So first time if I substitute A, I'll get 0, 2 and here 2, 0. Next time for B. For B is with what? A, B, B. So with this again I can substitute for 1A, I'll get B only. If I substitute for A, I'll get B. B is already there, so I'll keep only 1. Next I can have B epsilon, I'll get A. So these are the rules what I got after eliminating my epsilon productions. I think this is 1B. So it is 1B. So I can get 1 is with A. Next time I will also write B because I didn't had this 1. It is 1B. It is not only B. So if I substitute for B, I'll get A. If I substitute for A, I'll get B. Next is if I substitute for this B, I'll get 1. So these are the rules what I get after substitution of AB with epsilon. So A, I'll get B. For B, I'll get A. So these are the rules what I got after substitution of epsilon production. Is this clear? Is this clear for everybody? Anybody of you unmute? And tell me, is this clear?
Yes, ma'am. Yes, ma'am.
Is this clear?
Yes, ma'am.
So we'll just move with next last one, that is eliminating unit production. So what is unit production? The production which has both non-terminal on the both the sides. Single non-terminal on the both the side is called as unit production. Now how to eliminate unit production first? Now again, unit production, first identify all those which tend to unit rule. So if I just take this example, if you have a production of form, so I'll just take an example, S of AB, so P, next A with A, so unit production is given. Now which are the unit productions which tends to have both non-terminal on single non-terminal on both the side. So in this first step is you have to identify all those unit variables which which tends to single non-terminal. So unit variables are, if you observe this is 2, so no unit production. This is also no. B with C, it is an unit production because both the side it has single non-terminal. C with D also is unit production. D with E. So all these three are unit production. Other all are combinations of terminals and non-terminal. So first step is you have to first identify unit variables. That means the variable which tends to single non-terminal or a variable, I call it as unit variable, and the variable which has having unit variable, I call it as unit production. So in this given rule, which are the unit productions which tend to terminal string? Is this clear for everybody? Anybody of you can unmute yourself and tell me. Is this clear?
Yes. Yes, ma'am. Yes, ma'am.
Yes, ma'am.
So which are the unit productions which generates non-terminal on both the side? We call it as unit production. So in this example, these three are unit production. P with C, C with D, D with E. Other all productions generate your terminals and combination. So only single. So second step is again the same thing. See, identifying unit production is just by seeing your grammar. Second one is you have to remove unit production again by using substitution method. Unit production can be removed by using substitution method. Now again, substitution method is you have to substitute a variable with its corresponding rule defined. So in this case, now if you just observe S of AB. So S of A, in S of AB, you have B with unit production. So keep this as it is first. Next is A with A. Keep this because it is terminals. So here also you have two variables. So it is not an unit production. Next with B, you have a unit production C. Now for C, B there is no any issue. So keep this B as it is. Now C is a unit production with, when concerned to B. So C you have to eliminate. C can be substituted with D first. See, this goes on eliminating unit production. See, you have B with C with this. So I have to eliminate this. So how to eliminate this? C has one more rule D. So again D can be substituted with E. But all three are unit production only. So go on substituting that with corresponding item, corresponding rule until you get all with rules. No, until you get all the things which will not have unit production. See, for C you can substitute D. For D you can substitute E. Okay, E has what? E with BC. So B is already there initially, but for D you can substitute it with E. So D can be substituted with E and BC. All the rules I have to substitute. So initially B with C is defined. C can be substituted with D. D can be substituted with E slash BC. Again, with if you just observe, E is unit production. So E can be substituted with D, A, B. Then this you attach it as it is. So if you observe here, with B you get this rule. B, A, B, B, C, B. So B with C, unit production is been removed by substituting it with this rule. So how you have removed B with C? C is an unit production. B with C is a unit production. You have to eliminate this by using a substitution method. That is, for C, I can substitute it with D. For again, D is unit production. D can be substituted with E with BC because E with BC is defined for D. Again, E is a unit production. E can be substituted with DAB. So entire with B you can have this rule where I have eliminated all my unit production. So same way you do it this for your D part. So with C. Next is with D. C with D. So C with D is the next unit production. So for C with D there is only this defined. So again I have to eliminate it. So for first one, so in this case, you have B with C unit production. I eliminated it by using substitution method. Next left out is C with D. Again C with D. D is a unit production which can be substituted with E, B, C. Next again E is unit production. If I substitute with D, I get E has substitution. E has unit production. Again C with E I have to remove. With C, E if I remove, E can be substituted with what alternative? D and AB. So I have to substitute it with DAB. Then this BC is already there. You keep this as it is. So I have eliminated D with unit production. So I got this rule. So after substitution method, I got these things. Next, which is unit production? D with E. So again I have to try this only. D with E. So E again is a unit production. So E can be substituted with DAB. So DAB. So E can be substituted with DAB, and you already have BC here. Keep this as it is because it is not an unit production. Next with E. E is not an unit production. So I can directly write this as it is. So this is what I get after eliminating unit production, my rule. So this is my final answer after eliminating my unit production by the given rule. So first step is identify unit variables. Second step is by using substitution method, go on eliminating unit productions. So this is how we go for unit production, elimination of unit production. See, remember, if a question is given and you have epsilon rule in that and they have asked you for unit production, elimination of unit production, then first you have to eliminate epsilon production, then go for unit production. Understanding? Sometimes they directly give you only unit production, you are eliminating. But sometimes if in this case, if you had epsilon, first you have to remove epsilon production, then go for unit production. Understanding? So this is how we eliminate unit production. So we'll take another example for unit production elimination. So I'll just take another example for unit production elimination. So eliminate unit production. So S with A0B. So in this there is no epsilon production. They have directly asked you unit production. So if in this case epsilon was given, then first you will apply epsilon, then unit production. Now in this question they have only asked you eliminate unit production. But remember always, whenever if they have asked you to eliminate unit production and if somewhere epsilon is there, you have to first eliminate epsilon production, then go for unit production. We'll take that all together in the next examples. Now here we'll only go for eliminating unit production. Now first step is identify the unit production. So S of B is a unit production because single. B of A is also a unit production. Then A of B is a unit production because you can easily make out single variables, that is non-terminal. So second step is you have to eliminate it. So S of A0 for S of B is a unit production. So B can be substituted as what? A11, that is this. For B I can substitute this. Next again with S of A you have unit production. So again I have to eliminate this A. So A can be substituted with 0, 1, 2, B because I have to eliminate A with this all. Then keep this 1, 1 as it is. So I have eliminated A with this. But when I see this, again B is an unit production. B again I have to go with the A11. So A11 is already there. So ultimately your rule will be only this. Because however I go on substituting B again I'll get A11. Again A I have to substitute it with 0, 1, 2, which is already repeating. So repetition you will not keep. So B if I substitute with another value, that is A11, A again I have to substitute it 0, 1, 2, which is already there. So this is what I get after eliminating unit production for S. So this I'll keep this as P. So after identifying unit production, I got P dash and this I'll keep it as P double dash. So what I got P double dash, finally answer for yes, it is A0, 0, 1, 2, 1, 1. So I got this. So this is how I eliminated unit production. Next with B I have to do. So again B with A11. A11 is not unit production. B with A is unit production. So again I have to substitute A with 0, 1, 2, B, 1, 1. Keep the last one as it is. So let me do it here. So I'll take here B with A, 1, 1. So A I have to substitute it 0, 1, 2, B, 1, 1. Again, see here also, if I substitute it with B I have to again substitute it with A11. Again, A I have to substitute it 0, 1, 2. So I'll keep 0, 1, 2, 1, 1. So B with 0, 1, 2, 1, 1. Because it is alternate, S with B, B with A with B. Only for such type of example, it is repeating. Okay, we'll keep the same thing because B I have to substitute it with A11. A again I have to substitute it with 0, 1, 2. So one production, I'll keep it only once. So I'll keep this. Next is your next dot left is A with B. So I'll take this rule. So I have next rule A with, I'll keep first one as it is, that is 0, 1, 2, B. So B I have to eliminate with A. So B I can substitute it with what? A11. So again A I have to substitute it with 0, 1, 2, B. Again B I have to substitute with A11. So I'll keep with A what? Only 0, 1, 2, 1, 1. So this is what I got after eliminating my unit production. Is this clear for everybody? Is this clear? Anybody of you can answer. Is this clear? Anybody of you can answer me. Is this clear? Sampada, tell me, is this clear? This is what we have taken today is what? Simplification of your grammar. That is elimination of useless production, elimination of unit production, elimination of epsilon production. Anybody of you can answer. Is this clear today's part? So yes, what is the summary of today's class? We have understood 3 methods of a simplification of context-free grammars. One is elimination of useless production. Second one is elimination of unit production. Third one is elimination of epsilon production. So we have taken two examples each. You can even refer many questions from your exercise part of your textbook, that is Ellen Rich textbook. Many exercise examples are given. Even you can refer Hopcroft book or Martin Richard book. All are with automata theory and computability. Even you can refer Padma Reddy book for more examples. Examples you can take and you can solve these things. So elimination of unit production, epsilon production, and then useless production. So sometimes they will ask you to eliminate unit production, where they also give you what? Epsilon in that. So first you have to eliminate epsilon, then go for unit production. Is this clear for everybody? Is this clear? Anybody of you can unmute, no?
Yes, ma'am. Clear.
Are you there or not? Anybody of you can unmute? Asha, tell me whether understood or not.
Yes, ma'am. Understood, ma'am.